Hello everyone, my name is Rishabh Sharma and today I am going to present our paper titled An Exploratory Study on Code Attention in BERT. Pre-trained language models such as BERT are widely used in software engineering and natural language processing. These model uses transformer architecture and have achieved state-of-the-art results in many downstream tasks, some of which include code summarization. Previous studies have shown the similarities and dissimilarities between the programming languages and natural languages. However, current studies in software engineering rely on the reasoning and practices from natural language processing for these models in software engineering. Therefore, assuming similar behavior of these transformer-based model on source code by directly applying the NLP knowledge may not be appropriate. Hence, this work evaluates the BERT model trained on code corpus. In our study, we explore the attention behavior of BERT on different syntactic types and its semantic properties. We use the popular dataset named CodeSearchNet provided by Hussein et al. We clean this dataset by removing all the code comments in source code and tokenize the source code using the Java-Lang parser. The processed dataset is then used to pre-train the BERT model. We pre-train the BERT model on both mass language modeling and the task of next sentence prediction using the official source code provided by the authors of the BERT model. The pre-trained model is used to extract the attention map for the analysis. BERT introduces special tokens, namely CLS and SEP. CLS is supposed to learn the knowledge of the whole sentence, and SEP token is used as a separator between sentences to highlight the end of a sentence. As shown in figure, both the special tokens have very low attention value, which means BERT has little focus on CLS and SEP tokens when modeling the source code. This reduces the significance of special tokens in learning the relationship of code tokens. This result is contrary to what has been seen in NLP study, where 0 to 0.6 attention score is provided to these special tokens over the different layer. However, the score over here ranges just between 0 to 0.1. Attention score of the relative positioning of tokens reveals the long and short range of attention distribution learned by the model. As shown in the figure, BERT focuses less toward the token itself when compared to attention towards its left and right token. This is similar to what we have seen in NLP, as BERT attends more towards the local tokens in the English language as well. BERT uses a multi-headed attention mechanism to learn the representation of tokens. These heads are expected to learn different language features. To understand this information, we use the Jensen and Shannon divergence between different attention heads in the BERT model. Our result shows that middle layers retain the diverse information compared to the lower and the higher load. Code contains multiple syntactic constructs such as identifiers, separators, and data types. These code constructs are not available in natural languages like English. As shown in the left figure, the model puts most of its attention over the identifiers inherently, which is a possible explanation for its good performance on the code-based model, as the previous studies have acknowledged the importance of identifiers for easier program understanding. Between identifiers and separators, identifiers have higher attention values. The attention plots for other syntactic types, including operator, data type, keywords, and access modifier is shown on the figure right. Their attention scores are very low as compared to identifiers and separators. Now we investigate the syntactic abilities of BERT by masking the different syntactic types. The aim of this experiment is to know whether BERT can accurately predict the syntax type of the missing tokens that follows the Java language syntactic rules. In this task, we mask the tokens available in the code. We first mask all the identifiers within the code and test the ability of the BERT model in predicting the identifiers. Similarly, we repeat this experiment for data type, decimals, keywords, modifier, and others. As shown in the table, overall, BERT can correctly predict token type for all the syntactic type except decimal, integer, data type, and keyword. The lower score of these types can be related to the lower attention values they receive during the modeling. We use the code clone detection to analyze the semantic ability of BERT in each layer. In this experiment, we use the embedding of code sequence at each layer of the BERT for identified code clones. To comprehensively analyze the effect of embedding of each layer for code clone detection, we freeze the weights of BERT model because we want to learn the model's capability on the target task without further training the BERT model. For fine-tuning, we use the big clone bench dataset. The output representation of CLS tokens starting from layer 1 until layer 12 is used for the classification, as it's a standard practice to use CLS token representation in NLP and software engineering. As seen in the figure, the lower layers have lower performance as compared to the upper layers. This means upper layers are better at representing the semantic relationship of code. Therefore, semantic tasks should use upper layers to represent the code to get the best performance. We perform a similar experiment for code clone detection. However, rather than using the CLS token representation, we use the identifier token representation. To incorporate the representation of identifiers, we calculate a weighted sum of all the identifiers present within the code. The result shows an increase in the performance at all metrics, therefore which verifies our finding that identifiers in place of CLS token can be more useful. In conclusion, in this work, we presented an attention behavior of BERT for code and compared it to the attention behavior in NLP studies. We find that identifier and separator gets most amount of attention. Finally, I would like to thank my co-author